Thank you. Can you hear me okay? So this is so nice place that I don't want to mess this up, so I breathe it down. Good morning, Budapest. Oh, sorry. Just kidding. Bună dimineața, Bucuresti. Okay, so I got already introduced, so not a lot about myself. So I work for Microsoft in Microsoft Threat Intelligence Center. So my job is to keep you guys safe. So doing my dream job, I try to break things up, and then I'm helping our guys to detect and prevent those attacks. Okay, so I'm also the guy who made that tool. I have some stickers with me, so if you want to have one, just grab me after the talk. And I've been speaking a lot in different conferences. This year, maybe 10 or something. Last time I was here, I was working for that company, SecureWorks. But I joined Microsoft this year in January. Now, what I usually do when I go to places, everybody has their own things. I do running, okay? And last week, I had 2 conferences in the in the US, and I explained them that I like running. And this is from San Francisco. Back in 22, so I took an Uber to the end of the Golden Gate Bridge and then ran to the center of the town. And they were like, that's very crazy. I did the same next to Mississippi, and I tried to explain them that 2 years ago, I was able to run. I used to do like 1,000 kilometers per year before my hip got operated, and this is what I showed them, and they don't understand the scales we are using, so I changed this to miles. And they don't know calories, so I changed this to Big Mac burgers. So I spend that much energy every year by running, and I haven't been able to do that for 2 years. So when I booked my ticket here, I upgraded it to business class, and I got a seat 3F, but then I got to know that, okay, now it's moved to 2F. I was, okay, maybe the plane is full or something, but this was from yesterday, so I was the only guy sitting in the whole business class. And I was wondering that why did they move my seat? So then it turned out to me that, okay, this is the reason. So there was only one fat guy in the business class, so when they moved me one seat ahead, we got it in balance. So I took that as a hint, and this morning I went for a 4K run. So I was running here, so now it feels good and I'm getting better, so I'm going to do that again. Okay, then to the point of the talk. So I'm talking about token-based authentication attacks. First, a short introduction, then I'm going to talk about federated authentication methods, then about attacks, and then how to detect and prevent stuff. Okay, so let's start with the technical thing, general HTTP authentication framework. So basically, what happens when you type in your address to your browser, your client goes to the server and says, give me some information. And then the server says, okay, you are not authenticated, so please do so. So it sends back an error code 401, and it says that please authenticate using this scheme I'm supporting. And then some magic happens on your computer, and then you get another request with authorization header that says which scheme you are using, then the actual payload. If the server is happy, it will send stuff to you. And usually after the first authentication, we are using session cookies so that we don't need to do the authentication all the time. And here are some schemes. Who remembers the basic scheme? Nobody? That was very good times, right? Because that was encrypted. The username and password were sent by encrypted with B64, so that wasn't even encryption. But anyways, we are focusing on this part of the protocol today. Some key concepts I'm using here during the talk. So first we have a user that is consuming services. Then we have a service provider that is providing services. And then we have identity providers who are providing identity access management services. So back in the days, long time ago, in the dark 90s, and maybe early 2000, we have this model we call silos. So the service had the service provider, but also identity provider. And you just had to trust that the service provider is storing your passwords safely, maybe even using password hashes in the databases. So what could go wrong here? And each service had their own identity provider part also. And every user used the same password in every service, right? Who is using the same password in multiple services? You are lying. So usually, back in the day, because my name is Nestori, it was Nestori1 exclamation mark. Okay. But anyways, here in this model, if an attacker was able to, let's say, compromise this service provider, usually you could use the same credentials in others too. And again, your username and password were sent over the internet to the service provider. And if you used like the basic authentication scheme, that was a not good thing. And back in the days, they didn't even have HTTPS, or they had, but nobody used that. Okay, and then we invented the federated authentication model, also known as single sign-on. So here you authenticate or send your proof of identity to identity provider, and that provider will send you a token of some kind, and then you access the service using that token, which means that none of the service providers knows your password, right? They only get the token. And this is what we are talking about today. And all this is based on cryptographic trust, which might be a little bit challenging if things that Chris described happens, because we might not be having a good cryptography in the future, but we'll see how it goes. Okay. Then I'm going to talk about 3 different federated authentication methods. I'm going to talk about Kerberos, SAML, and then OAuth. And let's start with Kerberos. So what happens here if you want to access a service? So user goes to identity provider, which in this case is domain controller, or actually some services running on domain controller, and you provide your proof of identity, which usually is username and password. It can be certificate or something else, depending on your configuration. And then you will get back a thing called ticket granting ticket. And then with that, you go back to the IDP and you say that, okay, I want to use this service. Please give me a service ticket. And then IDP says, here's your service ticket. And now with that ticket, you can consume the service. So in this case, the token you have is the service ticket. Okay, now what's inside the service ticket? So we have different parts here. So we have the ticket part that has information about the user, and that is encrypted using the server secret. So basically password of the server. And why this works is that the identity provider, which in this case is domain controller, it knows everybody's passwords. So it is able to encrypt this whole thing with that password, then send it to you as a user, and then when user sends that to the server knows its own password, so it can decrypt this. So this way it knows that you really are who you are. Okay. And Kerberos was introduced first time, I think it was 89, and the first public version was 93. And this is SAML, and this is from 2002. So what happens here? The user goes to service provider. Okay, I want to use the service. Service says, okay, you need to authenticate first. So go back to identity provider. Now you provide your proof of identity to identity provider, and you will get back a SAML token. And then with that SAML token, you go to service provider, and then you can access the service. And we have 2 flows. So we have service provider initiated flow, which is so-called normal one. And then we have a thing called identity provider flow, which is one of the techniques that actually made possible golden SAML attacks. Who has heard about those? Someone? Okay. So yeah, so that technique was used there, or one of the techniques that was used there. Okay, so what's inside SAML message then? So we have the assertion. There's attribute statement, which contains information about the user, like username, maybe email, maybe groups you are part of, your shoe size. It depends what you want to put in there. And then we have the authentication statement, which contains information about which authentication method you used. And finally, you have the signature. And that signature is created by using identity provider private key. And the service provider knows the public key, so it can verify that the signature is correct. But nothing is encrypted here, so it's plain text. It's based on XML, so it's a lot of overhead there, but that's basically how it works. Okay, then to the OAuth. OAuth is actually using a thing called JSON Web Signature, or JWS. Some people say JSON Web Token, but that's wrong. There are two types of JWTs. There's JSON Web Signature and JSON Web Encryption. But if you are saying JWT equals JWS, I can live with that. We can be friends. It's not that serious. But anyways, what do we have here? We have a header, which I always say Jose header, and it contains information like which key was used to sign this. Then we have the payload, again, information about the user. And finally, we have the signature. And that signature is, again, signed using the private key of IDP. And because the service provider knows the public key, they can verify that this is valid. And this came out in 2007, if I remember correctly. Yeah. Okay. Now, even though the talk is like technique or product agnostic, I'm using Entra-ID as an example for obvious reasons. So let's talk about the different flows in Entra-ID, that how you can get the access token. So first one is called ROPC, or Resource Owner Credentials Flow. And what happens here is that user goes to identity provider, and this works for clients, public clients like Outlook, for instance, or Teams. So you don't need to prove the identity of the client you are using, just yourself. So you say, I'm using Teams, I want to access Graph, for instance. So here is my proof of identity. It can be, again, username and password, certificate, it can be FIDO key, whatever you're using. And then you will get back access token, and then with that access token, you can access the service. Quite simple. But now what happens if you are using your own application, which is not so-called public application? So you need to prove that identity of application, because it might have a different access than our public client has. So here, the first part goes in the same way, but now you will get a code, authorization code, instead of access token. And now that code tells you, sorry, it doesn't tell you, but it tells to Entra-ID who you are, which application you want to access, and which resource you want to access. And then with that code, you go to service provider, and now service provider needs to prove identity of that application or service, username or password or certificate, and then the code that proves your identity. And then you will finally get the access token, which allows you to access the service. So this is a little bit more complicated, but anyways, this is how it works under the hood. What else we have? We have the hybrid authentication flow. So if you are using like ADFS. So how many actually is using ADFS still nowadays? 2 years ago, it was from Fortune 500 organizations, it was like 68%. Last week I checked, it's still 52% of Fortune 500 organizations using something else than Entra-ID. So here you try to access the service, you are redirected to the identity provider, which can be like ADFS, it could be Okta, it could be Ping, whatever you are using. And then you will get back some kind of proof of identity, which can be SAML token or JSON token. And then you can access the actual service. Okay. So a little sum up. So Enter ID is using three kinds of tokens, basically. So you have a access token, ID token, and refresh token. ID token tells you who you are. Refresh tokens access token tells who you are and which you can access, what you can do. And refresh token is used to renew the token when it's expired. And here are the summary of the various protocols I used in examples. Okay. So then to token-based authentication attacks. So why this is important, token-based authentication attacks? So how many of you is using MFA, for instance? Come on, more hands, please. That's better. So we have made it kind of like difficult for attackers to steal your identity as such, so they can't authenticate as you. So they might have like your username and password, but they can't do MFA for you. So that all MFA stuff happens before you get the token. So when you get the access token, it also have like claims about I used MFA and so on, I can access this service. So you don't need to have MFA of the user because we have the token. You can access services using that token. So that's the kind of the bad thing about this token-based authentication. So if you're able to steal the token, you can be the user. Okay. So I like graphs, so I made a graph about token-based authentication attacks, and this is like a process diagram. So let's start with this. So do you have access to secrets? I'll talk about that in a minute. So let's imagine that you don't, so you need to steal the tokens from the user, okay? But if you have access to secrets that you use to sign or encrypt the tokens, you can steal them. And if you have those, you can forge tokens, so you can be whoever you want to. And then you can use the token. Okay, now, if you want to steal secrets for Kerberos, what do you need to steal? Anyone? Server password, because that's used to do that. And for OAuth and SAML, you need to have the token signing key, right? But that's never happened to, at least for us. Yeah, MITRE attack. So we have at least 3 different techniques. So you have the stealing the private keys, forging web credentials, or stealing the tokens. And then you have the profit. So there's no technique for that, but anyways, if you're able to use those techniques, you will have the profit at the end. Okay. So realms. So this is how I think about things. So everything starts at the endpoints. So you steal the token or token signing keys from the endpoints. So it's either your user endpoint, or it can be the place where you store your secrets. It could be ADFS server or whatever you are using. And then everything else is cloud. So what do you think? Which part we have like more control or any control? Is it endpoints? Yeah. Cloud? Nothing. That's out of our reach, I would say. Okay, so then let's put the authentication rules here. So we have the user, and you steal tokens from the users, right? You steal the token signing secrets from IDPs, and then you use those tokens in service providers. By the way, what do you think is harder, stealing tokens or secrets? Who thinks it's tokens is harder? No, stealing secrets is harder. So this is usually done only by state-sponsored like threat actors because it is so difficult, but it's doable. But it's never happened to us, I think. Okay, so I still have some time, and because this is a hacker conference, I try to walk through these 2 slides. So what you can actually see from users' endpoints. So the token is the easiest one, okay? Then we have, these are some technical things, so I'm not going to spend a lot on these. So you can read about those later on. But the thing that you can steal is PRT cookie, which can be exchanged to any kind of token you want to, basically. There's ESTS auth cookie, which can also be exchanged to pretty much every token if you want to. And finally, if you are using like a computer that doesn't have TPM, you can steal keys that prove the identity of the computer. But that requires that you have local admin and no TPM. But for all of these other things, you only need to have user permissions. Okay, now what token to steal? So we have the access or ID token, and that's valid for 1 to 24 hours, 28 hours. Usually it's 1 hour. You have refresh token that is valid for 90 days. And with the refresh token, you can get a new access token. Then we have this funny thing called family of client IDs, refresh token, which means a family of Microsoft applications that are living in their own family. And if you have like refresh token to any of those like applications or clients, you can get access tokens to other clients too. Because usually you say that, okay, I want to use like my application to access Graph API, you will get refresh token, and you can use that only to get new access tokens to that service. But this kind of is different. You can get access tokens to those family applications. And then we have the PRT called primary refresh token, and session key, which you also need to have to use those. And with that, you can get access tokens to multiple clients and resources. Okay. Again, that requires admin permissions, and also you need to know users' username and password. But all the others just user permissions, so they are quite easily to be stolen. Okay, who wants to see demos? Okay, maybe then I'll show some demos. So stealing cookies, I'm just going to show you a demo about that. So I'm logged into Enter ID portal. Just as a normal user, I hit the hacking button or F12, and then I hit refresh. Oh, not like that. Let's try again. I hit refresh. Okay, this is a demo effect. So let's try again. F12, refresh. This works like a charm, not. That's better. So now I'm just going to search any documents that starts with EYJ, like here, because that's how the access token starts. But it didn't work. That's nice. Oh, that's better. So here we can see the authorization header. It has the bearer type, and then we have the payload, which is the JWS. Just going to copy that. And then I can take that to attacker controlled machine and use that. So what information this contains for this particular one, so we can go to jwt.ms, which again is wrong. And we can go to claims. And it shows, okay, this is for graph. Where's the application? And it's for AB Ibiza UX, which means just the portal. So now with this token, I can access Graph API as portal. Okay, if I do fast, I can do another demo. Who have heard about evil chinks? Some have, okay. So basically this is for phishing. So I have set up a local instance for this, If you go here, you can see that the URL is almost like correct one, but it's not. And then you can send a user a link. And you can ask the user to go there. And now this is proxying everything to the real Microsoft site. So when you type in here, you type in the password. Here, evil things got your username and password. I just don't want to show them to you because I know you're hackers. But yeah, so this is so easy. So now you have the username, you have the password, you have ESTSO cookie for the Entra, you have all the access tokens user have. So quite easy. Okay, then stealing secrets and forging tokens. Want to see demos of that? No? Yes? Okay. Let's do that too. So for the ADFS, I'm using my own toolkit. So let's do that. Okay. And I assume this worked just fine like 30 minutes ago. I'm on the right computer, yes. Okay. But demo effects are always good. Let's try again. Oh, my bad. It's about import module. Yeah, just getting old. So you need to, this is an example, the organization is using ADFS, you need to have local admin permissions to that computer, and then you can just export the token signing certificates like this. And now we have the certificates right here. Another thing is that if you are using a thing called desktop single sign-on, or also known as seamless single sign-on, it is using Kerberos. And for that purpose, if you want to log in as any user, you need to have a server secret for that computer account, which is Azure AD SSO ACC. And I'm going to try to do that too. So it's get AD in desktop SSO account password. Use the local host in this case. But you need to have credentials to do that. But you can do that if you have like compromised, for instance, Azure AD, Entra ID Connect Sync. Okay, so now we have the server secret. Now we go to a different computer. So I'm just going to show you how that works. So first, what we are going to do is that we are going to create a Kerberos ticket using that server secret, and then I'm going to exchange that to access token, and then I'm going to dump that access token. Now, what we see here is that this is for graph, and we used password and Windows integrated authentication, also known as Kerberos. Okay, the second one, we are going to create SAML token and sign it using the certificate we stole, and then we exchange that to access token, and then I'm going to dump that token also so that we can see what's inside that. And here, if we go to see this, we have password, and we have also MFA. And why is that? Because the SAML has a nice feature that you can add a claim that says that, okay, I already did MFA in on-prem, so please don't do that in Entra. So that's also a way to bypass MFA. So that's also why the golden SAML attack was so effective. Now, there's a setting in Entra which you can switch on, which says that don't trust MFA claims from IDP. So please use that. Okay. So let's move forward. So we saw some attacks, and now we want to detect that, right? Or you as a hackers, how you will get detected. Okay. So sources. So in order to detect something, you need telemetry, right? And if you want to find if somebody is stealing your token signing secrets, you need to have, of course, telemetry from the IDP. If you want to detect when somebody is using token from the user endpoint, you need to have telemetry from the user's endpoints. And then if you're running the service provider side, if you want to find the token theft and token signing keys theft, then you need to have both IDP and service provider logs to do that. Okay, I'm going to try to walk this through. So, for instance, if you have like your on-prem web server and you have your on-prem Active Directory, if you want to detect if somebody has stolen your token signing keys or server secrets, you need to have the logon events from your domain controller, then also usage logs from your web server, right? So if here in usage log there's an event, okay, user accessed my service, and there's no corresponding logon event, you know that somebody stole those secrets. They were like forging those tokens. Okay, then if you have hybrid identity, like if you are using ADFS in this case, so you have your on-prem Active Directory data, you have ADFS audit logs, and then you have Entra ID signing logs. So if here is a signing event that is not in ADFS or in your on-prem AD, somebody stole your ADFS token signing certificates. Okay, but now cloud identity. So you don't have any on-prem components, only the cloud thing. So you have Entra ID, and you have signing logs, and then you have Azure Web App, in this case, and you have the usage logs. So if you compare these logs, and again, if there's an event that is not here, it means that somebody has stolen our token signing secrets, which would be a big thing, and that has never happened, right? Okay, so how do you map these things? So each token has a claim called a unique token identifier, or UTI for short. So you just compare that if there are events in both logs with the same UTI, and then you should be safe. Okay, so I'm going to show a demo about this scenario. So we have a token test web app. User tries to access that. Web app says go authenticate yourself, and it goes to Entra ID, and now we have the signing log event. And then you go back to our app, and then you have usage log event. Okay. Oh yeah. I have another slide here. So that's for detecting like theft of token signing keys, which it's a rare event when you are dealing with us, but it can happen if you have your own like IDP. Now, detecting token theft. So I'm not a developer. If you are a developer, sorry about this demo. It's a crappy demo, but it works. So logging in Entra, this application could be difficult. I didn't find any easy way to do that, but there's an event that is fired called on ticket received. So whenever the application is getting a ticket, I'm studying that. So I'm getting the ID token part away from there, and I'm also getting the remote IP address where the request is coming. Then I'm logging those. And then you can add a new claim to the token. In this case, it's IP address. So the token has a claim that says that the user logged in from this IP address. Now I'm comparing the addresses. So if the IP address is different than where the request is coming from, I'm raising an exception. Okay. So let's see how this demo works. Alrighty then. So I have the application, and I'm just going to start this. And now, because I'm already logged in to this browser session, it automatically logs in. Oh, right. So here we can see that, okay, we already logged in as Diego. Okay, so let's try to detect if somebody has stolen our token signing secrets from Microsoft. So I have a log file here. I'm just going to copy this because I didn't build any automation. So I go to Enter ID. Not there, but here. I go to Log Analytics. Oh, I was there already. Okay. So I have some queries here. Then I'm going to paste my log here. Now when I run this query, it is comparing that UTI property. And it found, oh, let's put this to 7 days or something. So there's not going to be false positives. Okay, so we found 3 requests. And one is from today, and there's a couple of from other days. So we can see there's one UTI that says Hackety Hack. So that at least was queried by threat actor using token signing key they stole from us. Okay. So you need to have both logs to do the comparison, right? Now about the token theft. So this was token signing key theft. So how to detect token theft? So for that purpose, I need to go to application where it is. There we go. Token test. I'm going to go to token configuration and I'm going to add optional claim for my ID tokens. And then I'm going to see this one. So now whenever somebody signs in Enter ID for this application, Enter ID will add the IP address the client logged in from. That claim. I do that. And then I'm going to go back to the application. Going to stop that and start it again. No, thank you. And now we have an exception which says that token IP address, so it's whatever address we are now going to internet, is different that I try to access, which is localhost. So this is actually quite powerful way to detect that. And you can also, if you don't want to like break that and you just want to detect that later on, you can do the logging thing, log analytics thing there too. So let's delete all. Token test number 2. And we can paste the same log here. And it's just going to show you the requests that have different IP addresses. So like here, token IP was that, and the request IP was different. Now, we at Microsoft, we don't do this one. But if we detect that there might be some token that we are raising the risk level of the user, and then if you are creating your own context access policies, you can decide that, okay, if the risk level is medium or high, you can enforce re-authentication or enforce MFA or whatever. But for us, we don't block that automatically, because how many of you is using like Teams using mobile phones, for instance? So your IP address is changing constantly, so you would be blocked all the time. So we don't want to do that. Okay. We are almost done here. But let's see another thing. So what if you are using Entra ID, which is in public cloud, and then you are using Microsoft services? So how can you get the service provider logs? Is there anything you can use? There is something. We have a unified audit log, right? And then we have Microsoft Graph activity logs if the attacker is using Microsoft Graph. There are other APIs which we are retiring in a couple of months, which you can still use. And then you have also like audit log. So if somebody stole a token and changed something, so it will be also there. The unified audit log has events like if user used read email, for instance. Yes. But anyways, so even though if you are only using cloud services, you can detect if somebody stole our token signing key. But again, that never happened, right? Well, actually it did. But that was before my time. So Storm 558, which is a Chinese-based threat actor, so what they did, so they stole an expired Microsoft account, so not Entra ID, but Microsoft account, token signing key. So that's like hotmail.com or outlook.com. So that was, again, stolen. How? We don't know for sure. And then there was a certain service, Exchange Online, that has a misconfiguration that accepted tokens signed by this expired token signing key. And again, for consumer side, not for enterprise side. So that was a bad misconfiguration. And that allowed them to access email of 25 organizations. But they were not going to do that again. So rest assured that we are detecting that and we have prevented all that kind of things happening. Okay. So how to prevent? So if you want to prevent stealing your token signing keys, so you just need to harden things. Like if you are using ADFS or whatever you are using, if you are using Entra ID Connect, you just need to treat those things like domain controllers. So that's what the tier 0 means. If you want to prevent token theft, you need to apply zero trust. And that's a hype word which can mean anything. What I mean by zero trust here is that you can't allow people access your enterprise resources using their own laptops. You saw how easy it is to steal tokens, right? From users' computer with user permission. So just don't allow that. So only allows administrators to join devices, use Intune or some other mobile device management, endpoint device management, and then ship those to your users. And then if you are a service provider, always verify. Read the tokens, their content, also compare logs. Okay, to sum up, stealing tokens gives temporary access as one person. It's easy, but you can have access to one person for a certain period of time. If you steal token signing secrets, you have open doors as anybody in the organization. That's more difficult, but it's more lucrative for threat actors if you have resources to do that, because it's give you the keys to the kingdom. Now, this is a team sport, so you need to have logs and collaborations from both service provider and identity provider. And yeah, so I was going to talk about that. I don't use AI to generate content in my talks, but I ask AI to create a picture of me as an old guy yelling at cloud, and this is what came out. Okay, but with that, thank you for having me.
All right, I think, do we have any questions from the audience? Yep, we have a hand lifted over there. Unfortunately, we have time for just one question, so just hold on a second. The mic is coming to you. Keep your hand up. Yep.
Thank you for your presentation. Why do you think that zero-knowledge-based authentication, like secure remote password, is not that adopted by the industry?
Can you hold it a little bit?
So why do you think that zero-knowledge-based authentication, like secure remote password protocol, and all cryptographic protocol, is not that adopted by the industry?
So what was the first for zero? What?
Zero-knowledge-based authentication.
Yeah, well, okay. So this was about the token-based authentication attacks, and it doesn't matter which authentication method you used. You always end up having a token. So it doesn't matter how good you protect or which MFA method you are using or FIDO keys. After that, you will have to have the token. So that's why this attack is so powerful. So that doesn't protect from this. There are techniques like token binding, but I haven't studied that much yet.